In this video we are going to start the chapter Shape and Space 6. You can see the page number 66 in your textbook, and it is Shape and Space 6. In this chapter we will be dealing with the circles. So let's have a brief introduction about the circle. If it comes to the definition of the circle, what is the definition of the circle? So I can define it. It is the set of points in a plane which are at an equidistant from a fixed point. What actually is this? These all points, this boundary, if we will see, is the collection of points or set of points that are in this plane, in the plane of paper. This curve, or we can say this boundary, is actually what it is, the collection of points. If I will draw the line like this, or if I will draw the curve like this, it is what actually it is the collection of the points. It is nothing but collection of points. Similarly, we have drawn here the circumference or the boundary of the circle. What is actually this? This is the collection of points. So it is a collection of points in the plane that are equidistant. So every point is at a same distance from this fixed point. If you can see, every point from this boundary is at an equidistant from this fixed point, and you know this fixed point is called the center of the circle. And we have understood there is the longest chord, the line that passes through the center and touches the circle at 2 points, that's called the diameter. And the diameter divides the circle into 2 equal parts. Each part is called the semicircle. And we have the segment, like if I will draw here the chord, it will divide the circle into 2 segments. These things you have understood in your previous classes. You might have gone, if the line that touches the center of the circle to the boundary of the circle, from the line which is drawn from center to boundary of the circle, is called the radius, and the plural of the radius is radii, R-A-D-I-I. It is the radii. Now coming to our main topic, you can see there is written on the page number 66 basic principles. What are these basic principles? These basic principles we need to understand, because these results will be used in the coming exercises. So keep understanding each and every point and repeat the video if you feel that you have the doubt. You can see we have here many theorems, like circle theorems, many results, we can say, or we can say the basic principles. First is, in a circle there is a triangle. This is the center, and these are the 2 radii, and this is the chord. AB is the chord, and OA and OB are the 2 radii of the circle. So you can see here triangle is formed. Here this side and this side, they are equal. So I can say angle A is equal to angle B. Why? Base angles of isosceles triangle are equal. If a triangle is isosceles, what does that mean? If 2 sides are equal, that means a triangle is isosceles triangle. So their base angles, these angles are the base angles, so their base angles are equal. This is the first principle that you need to understand and that you need to remember. Now next point is about the tangent. Second one, first we will see what is a tangent. If I will draw a circle, here is the center O, a line that touches the circle at one point is called the tangent. So a line that touches the circle at one point is called the tangent, and this common point where circle and tangent touch is called point of contact. It is also called point of tangency. So this is the point of tangency. So if here you can see on the book, a tangent is a straight line that touches the circle at one point only. The angle between a tangent and the radius is 90 degree. So if I will join this point of contact and radius, then it will be perpendicular. That's the angle between this radius and tangent will be 90 degree. So what is it? The angle between a tangent and the radius. If I will draw here the circle, here I have the tangent, this is the point of contact, this is the center, the line that joins the point of contact, that means where the tangent is touching the circle, that point and to the center, this will be the perpendicular. If this is O, this is M, this is L, I can say OM is perpendicular to L. That means this angle and this angle, they are 90 degrees. So in a briefly I can say the angle between tangent and radius is 90 degree. So this is the second one. First one is, in a circle, when there is a chord and two radius are joined, triangle is formed. That triangle is isosceles triangle and base angles are equal. Second one is, the angle between the tangent and the radius is 90 degree. Now coming to the third one. Third one is, angle in a semicircle is always a right angle. You know the right angle, that is 90 degree. I will draw a circle, and here this is the center of the circle. Then I will draw the diameter. This diameter divides the circle into two equal parts. Each part is called the semicircle. So this is the semicircle, this is semicircle. Our third rule or third theorem is saying angle in a semicircle is always a right angle. So if this is the semicircle, if I will draw here the angle like this, this will be 90 degree. You should understand the opposite side of this angle should be the diameter. Then it is an angle in a semicircle like this. You can see here this angle, if I will keep it as x and this angle as y, you can see the opposite side to the angle in triangle, this the opposite side to the angle x is diameter. If diameter is AB or center is the O, and the opposite side to the angle y is AOB, that's diameter. So this is the angle in a semicircle, angle in a semicircle. So they are equal because they are 90 degree. If I will draw here the circle, you can see here this, let it be the diameter of the circle, and you can see if I will draw here the angle, this angle is here in semicircle, but you can see here this angle cannot be the 90 degree. Why? Here the opposite side of this angle is only the portion of the diameter. It should be complete diameter. Like if I will draw here the line and this will join here, then you can see this angle is opposite to diameter, or I can say the side opposite to the diameter is this angle. If I will keep it here x, this is y, you can see x is the 90 degree, this is not the 90 degree because this angle is in a semicircle. And similarly, if I will write here angle like this, you can see for this angle the opposite side is the diameter, so this angle will be the 90 degree. So third result, we will remember what is that? Angle in a semicircle. Angle in a semicircle is always 90 degree. This is the third result. Now fourth we will try to understand, that is the angle at the center of a circle. You can see this is O, you can see here, let it be angle AOB. This angle is angle AOB, and this angle has been subtended by this arc AB. So the angle is subtended at the circle, at the center of the circle. If the same arc subtends the another angle at some point on the circumference, you can see here, let it be x. So what does it mean? This arc AB is the arc it is subtending two angles. One angle is at the center and the other angle is at the circumference. You can see this is the center and this is the circumference. This angle is at the center and this angle is at the circumference, but both the angles are subtended by the same arc, that is A and B. So what does the fourth theorem tell? It is the angle at the center, so this angle is twice the angle at the circumference. So if this is x, this will be 2x. For example, if this is 30 degree, this will be 2 into 30, that is 60 degree. For example, if this angle is 100 degree, so this angle will be half of the 100, that's 50 degree. If this angle is 20 degree, this angle will be the 40 degree. If this angle is like angle at the center is 90 degree, then this will be half of the 90, that is 45 degree. So the fourth one is the angle at the center of a circle is twice the angle at the circumference when both are subtended by the same arc. This is the fourth result. You can see the fifth result is, if we have a circle and I am drawing here the quadrilateral, which quadrilateral A, B, C, D, or the vertices of the quadrilateral, that means all the corners of the quadrilateral lie on the same circle. You can see A point is on the circle, B point is on the circle, C point is on the circle, D point is on the circle. So this quadrilateral is called cyclic quadrilateral. Why it is called a cyclic quadrilateral? Because all its points, all its vertices lie on the circle. You can see here all the vertices are on the circle, and these vertices, that's A, B, C and D, are concyclic points. Concyclic points, you should remember this. And one more thing is there, if this angle is x, this angle is y, this angle is A, this angle is B. If a quadrilateral is a cyclic quadrilateral, then the sum of its opposite angles, that's A plus B, is 180 degree. X plus y is 180 degree. This is the fifth one. And sixth one, we should remember, angles in the same segment are equal. What is that? If I will draw the circle here, here is a chord AB. So this chord divides the circle into two segments. One is major and one is minor. You can see this is the angle in a segment. This angle, opposite side should be this chord, and this is another angle in the segment, and this one is another angle in the segment. You can see here AOB, ABC, ABD, AB, E. You can see this angle C, ACB, ADB, AEB. These all angles are in the same segment. For every angle, the opposite side is AB, chord AB. If this is X, this is Y, this is Z. Sixth rule says us X is equal to Y is equal to Z. That means all the angles in the same segment are equal. In short, we can write angles in the same segment are always equal, or are always equal. Now exercise 1. It is page number 67. You can see the question 1. Find the colored angles. Explain your reasoning. So first question is like this. Here it is the center. This is OC. This is AO. This is B. and this angle is shaded one. Measure of this angle is given 160 degree. This is O. We need to find the angle B. You can see here angle AOC is 160 degree. If I will talk of the reflex angle AOC, what is reflex angle AOC? You can see here it's A, it's O, it is C. This one is 160 degree. This angle, this is reflex angle AOC, and it will be equal to 360 degree minus 160 degree. So I can write the solution like this. Reflex angle AOC is equal to 360 minus 160, that is 200 degree. How? Because angle around a point is always 360. So what is the measure of this portion? It will be 360 degree minus 160, that's 200. Now you can see angle ABC I can write, or twice angle ABC is equal to twice angle ABC equal to reflex angle AOC. That is angle ABC is equal to, what is reflex? That's 200 degree divided by 2, that is 100 degree. So angle ABC is equal to 100 degree. Or in a short, here you have to give the reason for this. What is the reason? The reason is angle at the center of a circle, angle at the center of a circle is twice the angle at circumference. This is the reason for this twice angle ABC will be equal to reflex angle AOC. You can see the question number 2. It is, here is the center and here is angle, it's AC. This angle is subtended by the arc AOC, and one more angle is there subtended by the same arc, this angle, and it is B here. This angle is 300 degree. So we will find first angle AOC. Angle AOC is equal to 360 degree minus 300 degree, that is equal to 60 degree. How? Because angle around the point will be 360. This portion is 300 and this will be 360 minus 300, that's only the 60 degree. Now here angle ABC will be 60 degree divided by 2, that is 30 degree only. Why? You can see here why. Because angle at the center is twice the angle at the circumference of a circle. I can write angle at the center is twice the angle at circumference. This is the answer of the question number 2. Now you can see the question number 6. What is the question number 6? There is a diagram like this: A, B, D, and this is C, this is O. We need to find this angle. This angle is given. So I will write angle ABC equal to 180 degree minus 70 degree, that is 110 degree. How? Sum of angles on a straight line. This is the straight line, and sum of these two angles will be 180, and we know this angle is 70 degree. It means this angle will be 180 minus 70 degree. The reason will be sum of angles on a straight line is 180 degree. This is the reason for this. So now this angle I know this is 110 degree. Now you can see this angle will be reflex angle AOC. Reflex angle AOC, that means this angle will be twice this angle. That's 2 into 110 degree. That is 220 degree. Why? It is the same reason we have used in the question 1 and question 2. Angle at the center. Angle at the center is twice the angle at circumference of a circle. So now we know this angle. Therefore, I can write angle AOC, that means this shaded angle will be equal to 360. That means the whole is the 360. 360 minus this portion, reflex portion, that's minus 220 degree. What is that? 0, it's 4, it's 1. So it's 140 degree is the answer of the question. Now question number 7. You can see it is A, B, C, D. And this angle is given, it is 30 degree. This angle it is given, and here is the symbol of 90 degree, so it is 90 degree. When this angle is 90 degree, this angle will also be 90 degree. Why? Because vertically opposite angles are equal. So I will find this angle, that is AD, let it be O, ADO, that's angle ADO will be equal to 180 degree minus 30 degree plus 90 degree. That means 180 degree minus, that's 120 degree, which is equal to 60 degree. You can see this is the triangle AOB. This is given, it is symbol is given, that's it is 90 degree. So this will be also equal to 90 because they are vertically opposite angles. Vertically opposite angles are equal, like this. This angle is equal to this. This angle is equal to this. So this is 90. This is 30. 90 plus 30 is how much? That is 120. So the angle sum property of the triangle, I have used angle sum property of triangle. I have used this property is 180 degree, or I can say angle sum of triangle AOD is 180 degree. I can write also this one. So I have got now this angle, it is 60 degree. Now you can see AB is the chord, and here this portion is the segment. Angle ADB is equal to angle BCA, because these two angles are in the same segment. So therefore I can write angle ADB is equal to angle BCA. You can see this angle and this angle. Why? Angle is in the same segment. Angle is in a same segment. Angle is in the same segment. So therefore angle BCA will be equal to 60 degree. This is the answer of the question. Now you can see the question number 11. In question number 11 you can see the diagram. This is AB and this angle is 35 degree. This is center of the circle, that is O, and this is X. We have to find the value of the X. What is the measure of this angle? You can see this and this, OA and OB, these are the radii of the circle. So angle 35, this angle will be equal to this angle. Why? Because they are the base angles of isosceles triangle. So I can write 35 degree is equal to this angle. This is what? Why? Because base angles of the isosceles triangle. So this will be also equal to 35 degree. And now I will find this angle. How? I will find like this angle AOB is equal to 180 degree minus 35 plus 35, that is directly I will write 70 degree, which is equal to 110 degree. So this angle is 110 degree, which result I have used here. Directly I can write angle sum of triangle AOB is 180 degree. I have used this. Now this angle is 110. This angle I can see here. You can see this AC is actually what? AOC. It is a straight line. So this angle I can find angle BOC is equal to 180 minus this angle. What is this angle now? 110 degree. So it is the 70 degree. So what is this? Here I can write sum of angles on a straight line. Sum of angles on a straight line is 180 degree. So now I know this angle, this is 70 degree. This is also the 90 degree because this BC is the tangent. So I can write here BC is I can write it angle OBC is equal to 90 degree. Why? Because angle between radius and tangent is 90 degree. So this is 90, this is 70. Now what is x? So I can write x is equal to 180 minus, that is 90 plus 70 degree. Sum of these two angles, that is 180 degree minus, that is 160 degree. So this will be 20 degree. Here what I have used, sum of angles, I have used here angle sum of triangle BOC is 180 degree. This I have used. You can see once again, you can see this here. It is the diagram. It was only given 35 degree. Now this is 35 because this is the isosceles triangle. So this is 35. Now we will find this angle, that is 180 minus sum of these two triangles, that is 110 degree. Now we will find this, since this is the straight line, this angle will be equal to 180 minus sum of minus this angle, that is 110 degree, that is 70. Now this is 90. Why this is not 90? Because we know the tangent at the radius at the point of contact will form the 90 degree angle. This is 90 and this is what? This is 70. Now how to find the x? Here angle BOC is the triangle, so sum of all the angles will be 180. To find the x, it will be 180 minus sum of these two angles, that is 180 minus 90 plus 70 degree, that is 20 degree is the answer of the question.